Out of some discussions we were having internally at Sixtree, somebody posted a URL of some latest blog about microservices architectures, etc. And my colleague Yaman said, "Oh man, if I read another microservices blog that doesn't mention events, I'm going to scream." Okay? And it's really kind of true. So asynchrony. It's a bit of an awkward word. Asynchrony is a prime characteristic of microservices. If you look at what people are writing about microservices, the communication across bounded contexts using asynchronous events is a very important part of the loosely coupled nature of microservices. But not many people talk about them. Okay? Your typical microservices blog or article is not going to mention it very much. And I did a bit of an experiment. I went and did the top 20 Google microservices architecture and looked at the top 20 results and threw out some of the things that weren't really articles. And out of those 20, 7 of them had a mention of asynchronous or choreography or events. And 3 of those 7 were articles by Martin Fowler or Chris Richardson, and they don't really count because you expect them to do. Okay? So where they did mention it, it was mostly mentioned in passing. Right? They'd make some reference to, asynchronous events are important, and we'll talk about that in a later blog. Or they would talk about loose coupling and how asynchronous loose coupling is a primary feature of microservices, but they didn't tell you how or why or any of that sort of stuff. So I really wanted to drill into this and talk about events, where they fit into microservices architecture, why they're important, why they're difficult, why you need to think about them and kind of understand them, I guess. Just a couple of links, so when this goes up on SlideShare. So the first link is to Chris Richardson. Some of you might know, so Chris gave a talk at this meetup back in January. He comes out for the tennis, so I'll see if he's coming out in next January. So Chris Richardson started Cloud Foundry, has written Pojos in Action, and he's very big into microservices architecture now. He wrote a really good article on InfoQ about microservices that goes into a lot of this stuff and talks about asynchrony in there. The other honourable mention there is a blog article that did the rounds a few months ago called Microservices and Not a Free Lunch. And that goes into asynchronous events in a fair amount of detail and basically from the perspective of they're really hard to do. Okay? So it's a good balanced perspective there. So why events? What's important, what's interesting about events? The way I'll introduce this, the way I'll sort of go into it, is to talk about an example microservices architecture for what I consider to be the hello world of enterprise systems, which is an online book selling site. Let's call it maribyrnong.com.au. Okay? So we've got this online bookseller and we've built this using a cloud-native microservices architecture, and you might know from microservices that there's this concept of bounded context. So domain-driven design is a very big influence into microservices architecture. Domain-driven design has the idea of bounded context where we've got different domains or subdomains within my business landscape which act as boundaries between the different service groups that we create. Okay? So as an example, in this online bookseller, we've got 4 domains here, the sales, or the 4 bounded contexts. We've got the sales bounded context where we're concerned with attracting people to the website, showing them catalogs, encouraging them to buy. Fulfillment is all about once they're bought, how do we get the books out to them, assuming they're physical books, that could be a really interesting area. Product is all about inventory, catalogs, managing all of that stuff, giving people something to browse through and put into their shopping carts. And then finance is all about how do we get money out of them and how do we keep that money and use that money effectively. So these are the different bounded contexts that we deal with. And if we look into each of those bounded contexts, so we've got different domain models within those bounded contexts. If you're like me and you've come from a bit of an SOA, a traditional SOA background, you might be familiar with the concept of a common data model or a common information model. And we've gone through this sort of progression over the years where we know that point-to-point integration is generally pretty bad, very brittle, very tightly coupled, and that's because we've got very specific data models that are talking to each other. So I'm pulling data out of SAP and I'm sticking it into Salesforce, and if that's a point-to-point interaction, I'm just pulling from one data model, mapping it to another data model, and that's a tightly coupled, very brittle integration path. Okay? Interestingly, so Beth's talk a bit earlier, just beforehand, talked about using hypermedia to decouple the actual file structure in the batch files from the semantics, if you like. So that's an approach of using hypermedia to remove that tight coupling, that brittleness of these data structures that we deal with. So having learned the lessons of these tightly coupled point-to-point integrations and where you have maybe hundreds or thousands of different data mappings that are occurring, one path that people went down in EAI and then into SOA was the idea of a common data model. So I'd pull stuff out of SAP, I'd map it to a system-neutral data model, and then I'd take it from there and map it to my Salesforce data model, okay? And I can do that for any number of systems I've got. It reduces the problem from an n-squared problem down to an n problem, okay? So that was the theory, and that's a good theory, but we've sort of found over the last few years that relying on one common data model to rule them all, you know, one data model to rule them all, is pretty unachievable. You end up getting a lot of brittleness just in that. You get this huge complex data model that pulls things in from all sorts of domains, okay? Eric Evans of Domain-Driven Design fame sort of recognised this several years ago when he wrote his book, and he said, look, you don't want one common data model, you want these bounded contexts where you've got a common model within a bounded context, but the models are allowed to adjust, to move. It's a bit like expansion joints in the model. You can make them different from one bounded context to another. So the idea, instead of having one data model for a customer, or instead of having 120 data models for a customer, we've got maybe 3 or 5. Okay, it's a much more tractable problem. So in this case, our sales context, we've got a data model for the customer, and we're representing within that bounded context all of the information that's important for selling our products to the customer. So we want to know about their name. It's nice to say hi Fred when they log in. We want to know their name, their age, their star sign, their demographics, their income, where they live, maybe who their friends are, what their propensity is for science fiction versus romance novels versus historical dramas, maybe what's their loyalty status. All of that kind of information is important to us when we really want to know the customer, get close to them so that we can give them offers, we can sell our products to them. And that's within the sales context. We're also interested in other things like maybe a wish list that they've put in. That looks like a good book, but I haven't got time to read it now. I'll stick it in the wish list for later. Maybe their order history, what they've bought in the past, what they're buying now. So give them the ability to create a shopping cart, stick some books into that shopping cart, and then go and check it out and create an order. So the colours haven't come out terribly well here, but basically those orangey sort of things are the sales context. They're the entities I'm dealing with in sales. The book representation is coming in from the product context. So my catalogue of books, what's the what's the products that I have on offer, what's the inventory that I have that's available to promise to the customer. That's all information that I'm potentially using in the sales context, but that's from a different bounded context. Okay. We can add to that the finance context. So within finance, I'm not so much interested in the customer's demographics. I've already sold stuff to them. They've swiped their card. I'm mostly just interested in their financial information. What's their credit card details? How do I hold that? How do I put that into a PCI compliant area and wall that off from the rest of the site? The fulfillment context is now where I've gone from the sales representation of the order. So that contains information about the book, its descriptions, its photos, its people's reviews of the books, their star annotations, etc. And I've gone more into a logistics perspective on things. So now, in terms of the customer, I'm really only interested in their address. Where am I shipping the book to? Okay. I need to know enough about the book to know where it is on the shelf so that I can pick it and pack it. That's the context I'm looking at there in terms of the book. And in the product context, this is where we're dealing with our inventory, what's on stock, what's available in the supply chain, what's on back order, what's in the catalogue, what are we selling this month versus what are we selling last month, etc. So they're the different contexts that we've got in our online bookstore. As you can see, the data models that we're using are slightly different across each of those bounded contexts. Okay? And that's kind of the necessity of building a scalable, reliable system. And what we're doing here is we're looking at these two attributes called cohesion and coupling. Okay? Cohesion is all about how well a subsystem performs its function. So my sales subsystem is all about attracting customers, allowing them to browse through the catalogue, create a shopping cart, and go do their purchase. So I want that sales subsystem to be cohesive around those functions. I don't need sales to be dealing with logistics information or maybe my supply chain information on the books. I don't want to pull all of that extraneous stuff in. Okay? I'm just interested in what's important in selling. Likewise, when I move to logistics and fulfillment, I'm not interested in the customer's star sign or their social network or anything like that. I just need the information that's necessary to get that book to their doorstep. Okay? So that's about cohesion. The other side, sort of the flip side of cohesion, is coupling. Coupling is about the propensity for changing one part of the system to disrupt another. And this is the problem with your monolithic common data models. If I pull everything in to my customer common data model, so I've got their social network, I've got their star sign and their order history, and I've got their fulfillment address, and I've pulled that all into one microservice, a very big microservice, then it's going to be pretty hard to change. If I change one thing over here in fulfillment, that's going to have ripple effects through to social networks maybe, and I don't want that stuff there. So coupling is all about how badly that sort of stuff leaks across the boundaries of these bounded contexts. And basically, coupling is evil. Right? Coupling is the thing that we fight against whenever we're building enterprise systems, because coupling is the things that make it hard to change your systems, make it hard to change your business processes, and make it very expensive to change your business in response to the changing needs. So, and everyone says it. You don't have to take my word for it. So this is something I came across recently. Steve Platnick is writing a book and doing some presentations around hypermedia, and he says it's very boldly. Coupling is the enemy. Okay. I think coupling is very relevant to microservices, because if you can think of a raison d'etre, what is the purpose of microservices? It's really to eliminate all forms of coupling. Okay? Microservices, a lot of people talk about how microservices can be difficult to work with. You must be this tall to take the microservices ride. There's no such thing as a free lunch. Microservices come with a lot of cost to them, but the cost is there in order to eliminate as much coupling from these systems as possible. So there must be some rationale behind why we're going to these lengths to remove coupling. Coupling is very insidious. Coupling sneaks into your solutions through lots of different vectors, if you like. So, a common one with microservices is shared databases. The whole idea of a microservice being this vertically sliced unit of functionality that owns its own database, owns its own independent data store, is so that we don't have a bunch of microservices all funneling into this one monolithic database where the source of coupling lies, okay? So if you slice things up vertically and separate them out, you're getting rid of one very important source of coupling. I've already mentioned the single common data model, this monolithic data model, is a very, maybe surprising to us 10 years ago or several years ago, is a very insidious form of coupling there. Another interesting one is DIY. Don't repeat yourself. I want to write my code once, I want to package it up, and I want to deploy it into all of my microservices. That's actually a bit of an anti-pattern. You might think dry is good, but for microservices, one single package that you share across those microservices actually introduces coupling into the system, and that comes with costs. There's benefits, you write the code only once, but there's costs in production because you get into dependency management problems with that. Okay. Another really important one, I think, that we're still kind of heading down a slippery slope on is code generation. Okay, taking an interface spec, whether it be a WSDL or a RAML or a Swagger, and generating my back-end Java code or generating my front-end client SDKs. That's building in tight coupling there because you're coupling the language features and the specs. I've had interesting examples where you start with a clean slate and you go, well, I'm going to build this Swagger specification and I'm going to make it a nice clean API, and then you find that when you generate those POJOs in the Java, the Jackson generators can't do what you want it to do. So you end up coming back and modifying your API because the backend language is Java, or because it's Scala, or because it's Node.js, or whatever it is. You get these leaky abstractions and language features leaking into your APIs. We had that with Corba, we had that with SOAP, we've still got it with REST. And I think it's really important to try and get away from those kinds of things. Organisational coupling, how projects get funded. The fact that the finance department is funding this project and that's our scope of work, and no, we're not going to pay for that other thing, which might seem like a good idea, but that's Harry's context, that's his silo over there, so we're not going to deal with anything there. So business processes, organisational structures, Conway's law comes into how we define projects and therefore builds in couplings into those types of things. So moving from a project focus to more of a product focus is an important way of removing some of those couplings. So this brings me to business processes. So we've got our online bookstore. We've got this end-to-end business process where we attract the customer in, we provide them some marketing offers, 10% off this book today on microservices, and people who bought Sam Newman's book also bought Eric Evans' book, and why don't you get that as well? So they fill their shopping cart, they swipe the credit card, we then send that order off to the fulfillment department, they pick it off the shelves, load it in the trucks, send it out to the customer. Customer gets it and goes, well, hang on, I didn't order this book. I wanted a romance novel. They'll send it back and we go through all of that process. So there is an end-to-end process which, as we can see now, is crossing these bounded contexts. Okay? So we need to orchestrate something that will go across those different domains that we've tried very hard to decouple. So that's kind of a problem that's facing us, is we're trying very hard to decouple our services into these bounded contexts that are nice and cohesive and decoupled, yet we have to support business processes that cross those boundaries. And what's the best way to do that? So here's an example of our business process. I've split it up into the types of orchestrations, the types of calls that you might make to your microservices. So the customer comes in, they browse the inventory. So that's a get of the products domain. So each of the little coloured hexagons is which domain I'm primarily working with there. So we first hit the products domain. We then create an order, so that's in our sales domain. We add books into the shopping cart. We specify what's the shipping address. That's still within the sales domain. Now we need to potentially get a shipping charge or a quote. So how long is it going to take to ship? Do I want expedited delivery, or do I want ordinary delivery? Maybe I'm dealing with a third-party logistics provider that's doing that, so I need to get a shipping quote from them to add that into the sales order. So that's where we're potentially crossing over into that fulfillment bounded context to get that information back. Okay? We then make the payment, so that's swiping the credit card, that's finance, that's their domain. We have to update the inventory. Okay, so this customer has just bought 3 of these books and 2 of those other books. Decrement the inventory, update maybe our marketing systems, update our systems that have, well, other people that bought this book also bought those books. That's within the inventory product marketing domain. Okay. We then move from the sales order into the fulfillment order. And we want to make effectively a copy there. We want to really decouple that, because potentially one sales order becomes different fulfillment orders. Okay? That book's out of stock, we'll put it on back order, we'll put the other books in and send them, and the back ordered book, that'll come 3 days later. Is that okay? So we need to have that really loose coupling. We can't just take a sales order and expect that to map one-to-one to a fulfillment order. Okay? So that's an important area where we have to decouple those contexts. We then go into fulfillment, so pick and pack, stick it on the couriers. The courier says, well, where does this go? They look at the shipping address, and then we go to accept delivery, and hopefully that's the end of it. Although potentially, no, that's not what I ordered, so it goes back, and we have to go back into maybe resales or refunding, which is part of the finance domain. Okay, so that's our business process crossing across all of these domains. So how do we do that orchestration? Okay, there's a couple of different options open to us. So the commonest way of doing this is using a centralized coordinator. Okay, it might be probably a lot of us, maybe from the enterprise space, are familiar with business process engines. So we might have a BPM engine that's orchestrating those calls, orchestrating that end-to-end process, especially if it's a long-lived process. Okay? More commonly, on the web, it's the user agent. So the person that's sitting there, clicking links in their web page, is actually operating as an orchestrating agent, fulfilling that business process for us. Okay? Another common way of doing that is maybe having a facade across our microservices APIs, which does some of that orchestration for us. So Netflix did that. If any of you are familiar with Netflix's earlier architecture, they created a one-size-fits-all API that all of the different devices or the movies would go to. So whether it's a web page or a set-top box or a mobile phone, when it came to the Netflix API, it would do this orchestration. And what they found was that it was very chatty, and very inefficient. So they created what they called the experience layer. They created a facade in front of their API that was tailored to a particular end unit. So a set-top box would go through the set-top box layer, and that would do the orchestration on behalf of the set-top box. Okay? So that's a fairly common process there. So orchestration has got its benefits. It's centralized, it's manageable, it's easy to get hold of, but changing it is very difficult, and it's kind of unnatural in the microservices domain. So it's often been referred to as the God object, right? It's the object, it's the thing that knows the end-to-end process, and when you have to change that process, you have to come to the God object and you have to persuade them to change, okay? A lot of work that's been happening in the REST area is around using hypermedia to manage that orchestration. So to make the orchestration a lot more fluid, a lot more changeable, on demand, if you like. And that comes back to Beth's talk earlier about using hypermedia to decouple some of the brittleness in those batch jobs using hypermedia. So with hypermedia, we can create a shopping cart. That might then give us some links into the catalogue. Each of the entries in the catalogue might give us a link that we can metaphorically, if we're an automated agent, click on that link in order to add that link into the add that item into the shopping cart. Okay? So hypermedia works very well within a bounded context, but we run into a problem at the edges, right? So if I've got to the end of my sales process, I then have to have a hyperlink that potentially goes and creates a shipping order from my sales order. That seems a bit unnatural to have the sales context know something about the fulfillment context or the finance context, etc. So hypermedia across bounded context seems like we're leaking through the edges. It seems like we're creating these couplings there. Okay? How much should one bounded context know about another bounded context? And what kind of corners are we painting ourselves into by doing that? I read an interesting article just recently. Jason Bloomberg, who used to work at ZapThink, he's now at Intellex. So he's been travelling around the world. He comes out to Australia fairly regularly, talking about SOA, talking about RESTful architectures over the last 10 years or more. And he wrote a bit of an article about microservices. He says that the interesting thing that's missing from microservices architectures is this concept of composition. How do I compose these services to support business processes? And he makes the bold statement that microservices is not so done right unless it means building hypermedia systems of microservices. I think that's it's an interesting assertion. I have some sympathy with that. So we've got these options to us. Orchestration, which is very common, but it's maybe not very good in the microservices architecture. If we're trying to get rid of all that coupling, then maybe orchestration is a bit of a cop-out. Okay, maybe we want to look at things like hypermedia. But to bring this into some perspective, even if we are doing orchestration with our microservices, we're still a long way from where we were 10 years ago or more, where we had things like, well, a lot of systems still have this. Database triggers and monolithic code, they're really, I guess, very tightly coupled systems, very difficult to work with. And the whole idea of microservices is to move down the coupling path. Even small increments can be big wins, if you like. So we're moving into orchestration, we're moving into hypermedia, and that's providing us some benefits in terms of loose coupling. But have we got there yet? Is there still some room to move? I'll probably skip through this, but I'm talking about business processes, but there's also problems around data synchronization. Having bounded contexts which are very independent of each other is our goal, but very often it's impossible to actually get that cleanness. We still need to synchronize data across these contexts sometimes. particularly if we've got off-the-shelf systems or cloud-based systems involved in our architecture. So data synchronization is another element where we're bleeding coupling across those contexts, across those boundaries. So I want to talk to you about choreography. This is now where we get to the events part of the talk. Choreography is not orchestration. Orchestration is kind of taking a process and moving it through that from step 1 to step 2 to step 3. Okay? Choreography is using events to choreograph that process. I can't think of another word. But it's using events to coordinate the activity across our end-to-end business process. Okay? Not doing tightly coupled, I've done step 1, now I do step 2. It's more around state transitions and being able to communicate and infer state between the different systems. Okay? Events are very decoupled, right? Events are typically published out by a publisher, and there's a number of subscribers out there that are listening to these events. And they're often going through some kind of subject-based addressing, so they don't necessarily know about each other. The publisher says, hey, I've created my sales order, here it is, I'm publishing it out there. I don't particularly care who picks it up, whether it's the fulfillment system or the marketing system or any other system, all of the above. I don't care, I've done my job, and that's it. I will trust that the rest of the organisation knows what to do with it. So publishers and subscribers are very loosely coupled. We don't have to build knowledge into each of them about the internals of each one. And they're also very resilient to change, whether that's planned or unplanned. If I'm bringing in a planned change, all of a sudden, the marketing systems need to be notified when sales orders are finished so they can go in the data warehouse and we can do some predictive analytics. Well, I can just stand up a new marketing system that's listening to those events from the sales orders. Sales orders don't need touching at all in that particular situation. Also, in the event of unplanned changes, a system outage. So one of the systems goes down, the other one comes up and takes its place. It continues listening to those events where it left off, and you can be a lot more resilient. Okay, I'm taking a lot longer than I thought. So choreography provides loose coupling, a lot of benefits in that respect, but there's trade-offs. Okay, as people have said, asynchronous events lie at the heart of some of the microservices challenges. Okay, the reason microservices are not a free lunch, the reason that you have to be this tall to take that ride, is because you have to be able to deal with asynchrony. You don't have one location, you don't have one BPM diagram that can tell you where you are in your process. You have to often infer that. Okay. So event-based choreography is easier to change, but it's harder to control and monitor. Very often we'll sort of get around this by putting in a distributed logging system. That's where things like Splunk and Elasticsearch and those kinds of solutions are really good for microservices because you can instrument all of the services from end to end. You're not coupling things together because all they're doing is publishing log events into some Splunk log, and they don't care where they go. And what we're doing at the end of that process is we're correlating them together, indexing them and sticking them in a dashboard. Okay. So in terms of coordination, don't just think about orchestration. Think about maybe things like hypermedia inside your bounded context, and think about events for communicating across the boundaries. So I'll skip through this a little because we're sort of running out of time. But modeling events, there's this duality between commands and events. And the central abstraction that we want to consider is a state model. Okay? So we're not talking about business processes. Orchestration is all about business processes. What is step 7 after step 6, and that's after step 5. State models are more about what are the different states that my system can get into, what are the allowed states and what are the allowed transitions between them. And these are really important when you're designing your services and it's designing the APIs for your services. Start with a state model, and those transitions, the blue arrows between the states, give you your API commands. Okay? So those transitions, the commands there represent how I move my model from one state to another. And that's referred to as HATI-OS. So hypermedia as the engine of application state. Right? The hyperlinks, the things that I'm doing there, are the ways that I navigate through an end-to-end business process. On the flip side, this is the part that not many people talk about, are the events. And I've created an equally horrible acronym there. Events are the notifier of application state, okay? So I can influence my application state by following hyperlinks, but if I'm an external bounded context that needs to understand some of what's going on, I can infer the state of the other parts of the business through monitoring the events that are coming out of that, okay? So here we now have a combination of commands and events. So on the user agent side, my customer is filling their shopping cart and making a purchase, and that's all through hypermedia commands. On the back side, we've got events which are notifying significant events to these bounded contexts. Okay, so the finance knows that, hey, we've just sold $100 worth of books. Ting, that goes into the end of day reports. My product inventory knows that, well, these 3 books have just been sold, so now we're down below a threshold, we need to order from the supplier. Or marketing says, oh, yeah, that's more information about this book's a hot seller, we need to increase the ones that we're going to buy. And then fulfillment, we don't need to explicitly tell fulfillment, here's a sales order. We just publish the sales order, fulfillment says, cool, another sales order, well, that's for the Queensland distribution centre, so we'll route it up there and get them sending it out. Okay. Event structures are really, they can be as big or as small as you want them to be. The important thing with event structure is give it enough information to say this is the thing that changed, and the external parties, all they need to know is where to go to maybe see the change. So you can package up what's the change that happened and put it in your event, or you can just say, hey, this shopping cart got created and here's its URL, and then the fulfillment system, if it needs to know what that shopping cart looks like to do the pick and pack, it can go to the sales bounded context, pull that shopping cart out, and then use that information. Okay. Concurrency, hopefully if you've done your architecture right, it won't be a big problem, but sometimes you can get into problems. But the important thing is, a lot of concurrency problems are due to me trying to copy a piece of data from one system to another. But instead of copying that piece of data whole as follows, if I notify changes to that data via events, then that becomes a lot more resilient to concurrency issues. Okay? And that's really the central tenet of event sourcing, which is another way of using events. Okay, so some event transports. How do I get those events out? A really good way is syndication, so an RSS or an Atom feed. That's a nice, cheap and cheerful, restful approach that's very common around the world. The positives are it's very easy, it's a well-known pattern, it scales. It scales to web scale. WordPress has demonstrated that effectively. The negatives are it's polling, it's high latency, it's not terribly efficient. Webhooks, that's another way of doing things. So at the end of my sales process, I can post a notification to fulfillment saying, here you go, here's an order. Problem is, we need to tell the webhooks where to go, which means either we're hardwiring information in there or we're creating a publish-subscribe mechanism. You're reinventing message queues, so why would you do that? Okay. Message queues are another really good way of dealing with this sort of stuff. Publish events onto those message queues, publish them on the topics. That takes care of the distribution. They're mature, well-known technologies. There's some good open source implementations. Some of the problems in message queuing revolves around reliability. In order to have a reliable messaging infrastructure, I need a reliable file infrastructure. So that means SANs, it means distributed clustered file systems. They can be really expensive and really difficult to set up. There's another interesting new approach which has come out probably several years ago. So Apache Kafka came out of LinkedIn. It's been open sourced into Apache. It's a distributed log. It's very much like that RSS syndication mechanism, but it's not polling. So if you can think of Kafka as an application that's writing events into a local log file, and then that local log file is reliably distributed across the organization, and then each of the consumers is tailing that log file. And the consumers have control over where they tail it. So they can actually, if they've missed some logs, they can actually go back. Oh, where was I yesterday? They can go back into that log file and start tailing further up and replay those logs. So it gives you a lot of that flexibility and power of atom syndication, but it's extremely, it's not polling, it's very highly performant and efficient. And the reliability is all handled at the application layer. So Kafka uses Zookeeper to make this a reliable, eventually consistent distributed log. Okay. Now, whether Zookeeper is easier to set up than a clustered file system, I'll leave that up to you. It depends. Okay. So this is event distribution. There's a whole other area called event processing, which I won't go into, but I'll just point out that they're two different things. What we're talking about here is event transports, getting the events to the systems that need them. But sometimes the systems that consume those events might need to be very simple. So simple events, I've got a new shopping cart, I'll turn that into an order. Or they might be more complex. So you might need to listen to multiple streams of events, correlate them together in order to infer the state. And that's where you get into things like CEP engines like Drools and Riemann, which we saw last month, Apache Storm, etc. That's a whole other topic. And if anyone wants to talk about them, that's great. So, to wrap up, bounded contexts are important in your microservices architecture because they promote cohesion and they promote loose coupling. And as we said earlier, coupling is the enemy, okay? But you need to decide how you're going to coordinate your data and your processes across those boundaries. Look at things like orchestration, look at things like hypermedia, and definitely look at events, okay? Events have many benefits in terms of loose coupling and resilience and those types of things, but they also have some downsides in terms of complexity, but they're an important tool in your toolbox. So learn how to use them, and then either choose to use them with your glasses on, or if you decide, no, events are not for us at this stage, then at least you're making an informed judgment about that. Anyway, so that's my talk. Thank you.
I'm sold on the flexibility of the event-based system. What's the pattern for detecting failure?
So, yes, that's an important one. So, failure is...
I can get a message and I don't know I didn't get it.
Yes, exactly. So, one thing I like about... So, with the syndication, it's left up to the client. And that's one reason why syndication is so easy, because you're just saying, you consumer, you keep your own log, and if you miss it, well, that's your problem. Okay? Now, that's fine if I'm looking at a blog, right? But not if I'm looking at trades, okay? Message queues, they're built around resilient systems. They've got protocols, they've got timestamps in them too. And they keep ledgers as to what's been delivered and what's not been delivered. So utilise them when you can. And Kafka, of course, has got all of that as well. So Kafka gives the clients abstractions to figure out, have they missed a message, and then ways that they can come back to it. So really, for those kinds of reliability is very difficult, particularly across distributed systems. So leave that to the experts. Choose a product, whether it's open source or proprietary. Choose a product that takes care of that for you.
Dealing with change across bounded contexts, we have shared entities across bounded contexts, and you want to make a change in one and not have it ripple through. Obviously, things like versioning, stuff like that. What are some other patterns you recommend in isolating change?
So keeping that the API as the only entry point of the bounded context is a really important thing. So we're only letting change leak out through the API, okay? And when you're dealing with the API, there's versioning, so you can run two versions in parallel if you like, and as long as you remember to deprecate the old version and switch that off after 3 or 6 months and force everyone onto the new version. Another approach is using, don't make any backward incompatible changes, if you like. So there's one of my favourite principles is Postel's principle, Postel's law, or it's also called the robustness principle. Have your clients ignore things that they don't understand. This is the basis behind a web browser. If I've got a new tag called SVG and I'm running IE6 and it doesn't know what an SVG tag is, it doesn't drop a stack dump and go, oh, I don't know how to deal with this. It just ignores it and carries on. So having that graceful degradation, okay? And then using hypermedia to decouple some of that, the brittleness that you get with having the clients have to know how to navigate through a process. So if I'm changing the information that's required, or if I'm changing the route that I take through a process, if I can abstract that change behind a hyperlink, then that's another way of making it more resilient.
One more question. We spoke about eventual consistency. Is there any way you can get this to work for immediate consistency as well?
So that's getting into the CAP theorem.
What's the question?
So the question is, I talked about eventual consistency. Is there any way of getting this to work with immediate consistency? And I think the reality is, if you need immediate consistency, you need a monolith, and you won't be going microservices architecture. Okay. So there's trade-offs. Yes. Microservices loosely coupled distributed means consistency is always eventual. Now, eventual might be seconds or milliseconds, but it's not going to be instant, it's not going to be transactional.